Hi everyone. In this video, I'm going to talk about the difference between classification and regression. So that can help you to distinguish between both and you don't get confused or clear the confusion about both concepts. Classification, in short, is about predicting classes, labels. For example, you are trying to predict whether the answer is true or false, yes or no, whether the gender is male or female, the email is spam or ham. So as you see, you have classes, you have labels, and you are trying to figure out or to predict what is the output for such a problem. And another matter notice for classification, it is just a matter of labels you have here. In other words, there is no preference between true and false or yes and no, right? So classification, usually it's about nominal variables. So it doesn't matter whether you are predicting male or female or spam or ham. They are just labels. They are just classes. Like if you are trying to teach a kid, for example, to distinguish between the type of fruit. So this is a very good classification problem because here there's no preferences between the fruits, and just the only matter you are trying to do is trying to teach the kid how to distinguish, how to classify or how to predict the class or the label of the fruit. So what is the label of this fruit? Is apple. What is the label of the other fruit? Is pineapple, and so on. So you are looking into, again, labels. That's it, and there is no preferences between them. Regression, on the other hand, you are trying to predict values. Again, so there in classification, we were trying to predict labels, classes, but here we are trying to predict values. For example, you're looking for the sale price of a house or car, or you're trying to predict the age of a person, or you're trying to predict the wind velocity, and so on. So you're looking for values. And keep in mind, the values here, of course, they have sense of ranking. Like if you're talking about a house price of 5,000 is less than the house price of 10,000. But in classification, it was just a matter of labels. Okay, so classification, let's say we are looking into predicting whether such an email is a spam or ham. Now here in this example, just I have assigned values in here so that you understand, you don't say, oh, well, here we are also trying to predict values. No, these values are just discrete numbers. They are just used to distinguish between spam, like I'm marking spam with number 1 and I'm marking ham email with number 0. Or otherwise, up to you. You may mark ham as number 1 and you may mark spam as 0. Okay, so the point is just you have labels and you are giving them numbers because algorithms prefer numbers. They deal with numbers, right? But for us, the interpretation for 1 means spam. The interpretation of 0 means ham, or vice versa. Again, there is no preference for which email should be assigned as 0 and which email should be assigned by 1, whether spam should be marked by 1 or 0 or ham should be marked by 1 or 0. Again, the number here, it is just to distinguish between one person and another. You can think of it as you are assigning ID to the student, right? Assigning ID to the student is this ID. The only matter for this ID is to distinguish between one person and the other in normal case, okay? But again, it has no preferences. Who got the ID 100 or ID 101, it doesn't matter. It is just a matter of label. Same like when we talk about picture classification or you are building face recognition. Then maybe I assign 1 to such person as identification and assign 2 to another person and so on. So why I put numbers here, so you do not say, let's say if I got spam ham email problem for classification, and then you check the column for whether the target whether the email is spam or ham, and then you notice all of them are 0 or 1. Well, if you see that, that doesn't mean this is regression problem, because again, algorithms prefer numbers. As a matter of fact, even if the column is just including spam and ham as a text, you need to map them into numbers. You need to assign such number to spam and such number to ham, so the algorithm can work, because again, algorithms prefer numeric values, and these numeric values, they are just markers. They are just labels, numeric labels assigned to each category. I hope that this makes it so clear, so you do not get confused when we talk about regression problem, as we're going in the next slide. Okay, now as regression, let's say you are trying to predict the home price, and the target value that you're trying to predict is a numeric, is real value, is 10,000 or 5,000. Now this one is not labeled. We're not giving ID to each house. This is the real value of the house, right? And again, there's a sense of preference, let's say, or not preference, ranking. If you buy a house of 10,000, is more expensive than buying a house of 5,000. But if we're talking about classification, if you're predicting spam is 1, doesn't mean higher in ranking of predicting email of 0. It's only a matter of label for classification, but here you have real values you are trying to predict. Okay, as a summary, so again, classification algorithm, we use it when our target variable is discrete or has discrete values. As I said, 0, 1, 2, 3. Now again, these are numeric values, I know that, but think about whether these numeric values has sense of ranking, or they are just numeric labels assigned to each case or each object. Okay, so again, classification, target variables must be discrete value. And what you are trying to do, you try to find the decision boundary which can help to divide or classify or distinguish between different labels, or between different discrete values. Again, why I'm saying discrete values? Because even if you have labels, as I said earlier, you need to assign values to each label. Again, algorithms prefer numbers, prefer numeric values. And as an example for classification, where you try to predict spam, ham email, gender, male or female. On the other hand, regression, the target variable must be continuous in nature, right? It's no more a matter of numeric labels, but it is continuous value in nature, like you are trying to predict home price, age, wind velocity, and so on. So when you give home price a tag of 5,000, this is a real value. This is not a numeric label. Okay. And what you are trying to do, so in classification, we said we try to find the decision boundary to distinguish or classify. In regression, we try to find the best line to represent the data, so we can predict for future observations. I hope that will clarify the difference between them, so you don't get confused again, or at least you understand which time you need to use classification versus which time you need to use regression. Thank you.